So I'm gonna prove or try to prove the difference formula for cosine. And so that involves 2 unit circles. So this is a unit circle, and so that makes this the point 1, 0 here. This is also the point 1, 0 there. Okay. And so I have 2 separate triangles that I'm going to draw here, and I'm going to do my best to make these straight. I think I can make them straight if I use this shape thing. So we have a triangle here, and then I'm actually just going to draw this dotted line here. Okay, so this is a triangle. I'm going to call this point Q, and this over here is point P, and this is point O for the origin. And I'm also going to label this with some angles. So this angle right here is angle U, and then this angle that goes just to this part is V. Okay, and that makes this angle right here U minus V. Okay, is everyone with me so far? If you're not, pause it, rewind it, and play it again, and hopefully that will help. So now I'm going to take the same exact triangle, but I'm going to draw it in a different location. So the first spot I'm going to draw it, this is going to be that first segment right there, and then we have our second segment is right about here, and then that spot is there. Okay, and this angle right here is again U minus V. Okay, so using a skill from geometry, actually, I know we hardly ever do that, but using a skill from geometry, what we are going to do is we know that these triangles are congruent, and let me label this point B, and let's label this point A. Okay, and this is still O here for origin. So we know that triangle POQ is congruent to triangle BOA. Okay, and we know that because of the side angle side property of congruent triangles. So we know that both PO and OQ have a length of 1 because they're both radii. And so those are the same length as OB and OA in my second triangle. So we know that this side right here and this side right here have a length of 1. And that also corresponds to this side right here and this side right here. Those have lengths of 1 because they're all radii. They come from the center of the circle and they touch a point on the outside of the circle. So that means since the 2 triangles are congruent, that means that the distance between P and Q has to be the same as the distance between A and B. Okay? All right, does that make sense? So those distances, and I'll highlight those here. So this distance PQ has to be the same as this distance AB. All right. Now I'm going to use the distance formula. So the distance formula for I'm just going to write it up on the top and to remind us. So the distance formula is the square root of the difference in the x values squared plus the distance in the y values squared. Okay. Now it's just easier to work with this expression if we don't have the square root here, and we can get rid of that by squaring the distance. And so that's actually what I'm going to do is I'm going to square both sides here. And if if the distances are equal, then the square of the distances should also be equal. And this is just going to help us algebraically. So first, starting with the length of PQ, which is this picture here, this first picture, the distance between P and Q is going to be, I'm going to use the distance formula, it's going to be the change in the x values and the change in the y values. So the x value for P, I don't know it, but I can find it based on the angle U. So P, the x coordinate is cosine of U, and the y coordinate is sine of U. By definition, that is the coordinate of point P. And the coordinate of point Q is cosine of V, sine of V. Okay? And then the coordinate of A is 1, 0. And B here, that coordinate is going to be cosine of U minus V, comma, sine U minus V. So this is just using the definitions of trig functions, which we covered in the last unit. So hopefully that makes sense. So this distance between using the left side of this equation, okay, so the distance between P and Q squared is going to be basically just the difference in the x values. So that's going to be cosine U minus cosine V plus, and that's squared, squared, plus the difference in the y values, which are sine of U minus sine of V, and that is also squared. So I just really use the distance formula here, which is just another Pythagorean theorem. This is really a squared plus b squared equals c squared, right? All right, so now I'm going to simplify this as much as I can. So I'm going to actually multiply out, it's not really simplifying, I'm multiplying it out so that I can get an expression here. So I'm going to multiply out this, and I'm just using the fact that a minus b squared, quantity squared, is a squared minus 2ab minus b squared. And I'm going to use that formula twice, once for the cosines and once for the sines. So that's going to give me cosine squared u. And when we're writing a trig function squared, just like when we write logarithm squared, we put the 2 here so that it's not ambiguous. If we put it here, it almost looks like it's the u that's squared, and that's exactly what that means. It would mean that the inside is squared, but we want cosine of u means cosine of u squared. Okay, so cosine squared of u means cosine of u squared, the whole thing squared. So we have cosine squared minus 2 cosine u cosine v, and then plus, sorry, this should be a plus here, plus cosine squared v. Then we also have, when we multiply this out, we get sine squared u. We also get a sine squared v, and then we have minus a 2 sine u sine v. So putting that all together, that gives us, and I'm just rewriting this. I'm not changing anything. I have cosine squared u plus cosine squared, sorry, not cosine squared, plus sine squared u. And I'm grouping those together for a particular reason. Hopefully we know what cosine squared u plus sine squared u equals from last time. Here we have cosine squared v plus sine squared v. And I just took, so this came from here and here, and now I'm taking these two to get those. And then plus, sorry, not plus, minus. We have minus 2 cosine u cosine v minus 2 sine u sine v. Okay, I wish I could fit that all in one line, but ran out of room. So cosine, this becomes 1, and this becomes 1 because that's the Pythagorean identity that we talked about last time. So now I have 2 here, minus, and I'm going to factor out the 2 from both of these. That 2 became here. And when I factor out a negative 2, that gives me cosine u cosine v plus sine u sine v. Okay? So that's just the left side of the equation. I just multiplied that out. I found the distance of P and Q. So now I'm going to do the same thing with the right side of the equation. I'm going to find the distance between A and B. Okay, this one's a little bit easier to do because one of the points has a 0 in it. So the distance, and I'll move over a little bit so I'm not running out of room as much. So the distance between points A and B squared are going to be, let me just put it on a line here. It's going to be the difference in the x coordinates. So we have cosine of u minus v minus 1 squared plus the difference in the y coordinates. That's just sine of u minus v minus 0 squared. And so I can multiply out this term. That's going to give me cosine squared of u minus v minus 2 times cosine u minus v, and then plus 1. And then we have just sine squared of u minus v. This squared is talking about, because this 0 isn't really there, we just have sine squared of u minus v. And then again here we notice that we have a cosine squared of u minus v and a sine squared of u minus v. So that's just equal to 1. And so this 1 plus the 1 from these two guys gives me 2 minus the 2 cosine of u minus v that we have here. And everything else being equal, look, I have a 2 and a 2. I have a minus 2 and a minus 2, right? So if everything else is equal, that means that this right here has to be the same thing as this right here. And so I'm just going to rewrite that. So that means that cosine of u minus v is equal to cosine u cosine v plus sine u sine v. And this is our first identity that isn't a Pythagorean identity. It is called the difference formula. Okay, and it's a difference formula for cosine. And we can do the same sort of reasoning, and we get the sum formula for cosine as well. So these are our first, these are the sum and difference formulas for cosine. In the next video, we're going to work with some of these expressions in an example. Just to clarify, you do not have to be able to go through this whole proof by yourself on your own. I just wanted to show you where all of this came from. I don't want to just give you this formula and say, just believe me. So I wanted to show you where it came from. It is true. I proved this one right here. You can use a similar argument to prove the sum formula, but I just proved it. There it is. Okay? So now we can use it with confidence. Right. I'll see you in the next video.